Equations. Yeah, you have been hearing of the third equations. Now, what do you mean when you use the expression or the third equation? That is what today I shall be teaching you. So take particular note of today's lesson. Yeah, my name is spelled QMP. Equations. In this lesson, I can simply explain equation to be two items of the same value. Yes, that is what an equation is. And in mathematics, we use a mathematical symbol, that is sign of equality. Yes, this is the sign of equality. It tells us that two things are of the same value. What are these things? Normally, we can represent those items or the things by variables. For example, A and B. So it means that A and B are the same. There is no difference. Whenever A and B are the same, then we say they are equal. For that matter, we can use this symbol, and this is what we call an equation. So, for example, if A happens to be 2, what do you think B will be if A and B are the same? Yeah, it's obvious that B is also equal to 2. Yes, that makes it an equation. So, for example, here we may have something like 2 is equal to 2. Yes, this makes it an equation. Okay, there are certain things you need to know about equations. Talking about equations, we have two sides. We have the right hand side of the equation, and then we have the left hand side of the equation. And once it is an equation, it means that both the right hand side and the left hand side should be the same. Do not forget the other one also. Yes, that really makes it an equation. So, for example, I can decide this time to write that A is equal to B plus C. It doesn't matter introducing the C, because what we are talking about here is that once we add the two numbers or the two variables here, we are going to get the first number or the first variable. So, for example, we can say that A is equal to 5, and if A is equal to 5, and then B is equal to 3, and then it is obvious that C will go to 2. So check it out. Now we have 5, yes, is equal to B 3 plus C 2. Yes, so it is still an equation, and that is what we are talking about. Yeah, so talking about an equation, we are saying that two items of the same value, or a number of items of the same value, but the left hand side of the equation and the right hand side of the equation should be the same thing. That is what we refer to as an equation. Okay. But how do we solve equations? Yes, that is very simple. Let's now consider our very first equation that we used. A is equal to B. Okay, fine. I can write something like A is equal to B minus C. If I write A is equal to B minus C, and I wanted to make B stand alone, what do I do? It means I must take away the negative C. Yes. How do I take away the negative C? I can only take away the negative C if I bring a positive C. So watch out. Here I have B minus C plus C. Once I have C here, it means the whole of this becomes 0. And once I have added a positive C to the right hand side of the equation, it means that I must add positive C to the left hand side of the equation. For that matter, I have A plus C. By so doing, I have A plus C, that gives me what? B plus 0. Yes, so now A plus C is equal to what? B. And you can simply write that to be B is equal to A plus C. Yes, this is one way by which you can solve an equation. Okay, fine. Now, let us assume also that we have this time a constant attached to the variable, and I wanted to make the variable stand alone. How do you do that? Okay, I'll use that as an example. So let's say we have 2y is equal to k. This is also an equation, and I wanted to make y stand alone. How do I do it? It is very simple. I have to divide through by 2. So I'll write it again, and then out of 2, yes, 2 goes into itself, so now you have y is equal to k out of 2. Yes. So whenever you have something attached to the variable, and you wanted a variable stand on its own or alone, we divide through by whatever constant is attached to what? The variable. Okay, that exactly works. Okay, fine. Let us use one applied example. For example, the formula for finding force happens to be F is equal to ma. This time we wanted the ma come to the left hand side of the equation. So what we do? We need something to make ma 0. And what is that? That is negative ma. So here we have F is equal to ma minus ma. And once you have added ma to the right hand side of the equation, it means you have to add another negative ma to the left hand side of the equation. So we have negative ma. For that matter, we have F minus ma. That gives us a 0. This is another way in which you can write an equation, and it is still the same thing. Okay, fine. Now, there are some equations that have names. This time, I'm going to take you through some names of certain equations. We have equation like ax plus b is equal to 0, and this equation is called a linear equation. We have an equation like ax squared plus bx plus c is equal to 0. This is also called a quadratic equation. Okay, and then we also have ax cubed plus bx squared plus cx plus d is equal to 0. This equation is also called a cubic equation. Yeah, we also have this equation V is equal to IR, and it is known as the Ohm's law. Yeah, we also have E raised to the power pi I plus 1, and that is 0, and we call this equation Euler or Euler's identity. And then the final one I'll take you through happens to be mu is equal to G, and then M1 plus M2. Yes. This is what we call the gravitational parameter. Okay, so these are some examples of forms of equations, standard equations that we have. But there are certain things I'd like to take you through. For example, we have ax plus b is equal to 0. Please take note, both a and b are constants. Both a and b are constants. They are not variables. The only variable we have here happens to be the x. Yes. And also, A, B, and C are all, again, what? Constants. They are not variables. The variable we have here happens to be the what? The x. Is that clear? Good. The same applies to the cubic equation also. A, B, C, and D. They are all constants. The only variable we have again happens to be the respective x. Okay, fine. But when you come to that of the Ohm's law, none of them is a constant. They are all variables. The V, which represents the potential difference of the voltage, is a variable. The I, which represents the electric current, is a variable. And then the R, which also represents the resistance, is also a variable. So there is no constant in the Ohm's law. Okay, fine. Now let us move on to Euler or Euler's identity. Now we have E raised to the power pi I plus 1, which gives us 0. Please, all the variables you see here are not variables. They are all constant. E is a constant with numerical value 2.718281828, yeah, and so on and so forth. Pi is also a constant with numerical value 3.142. I is also a constant, yes, and I happens to be the square root of -1. Yes, so it is also a constant. Yes, you know 1, 0, yes, they are all numbers. Fine. So that is what I can say about the Euler's identity. And then finally, we have that of the gravitational parameter represented by the mu. And then we have our G, M1 and then M2. Yes. We can say that the mu here is what? A variable, dependent on the numbers we have here. Now the letters we have here are variables. Yes, they are constants. Yes, that is how it works. For example, this G, universal gravitational constant, is 6.67 to the extent raised to the power -11 Newton meter squared per kilogram squared. The M1 and the M2 can represent the respective masses of the Earth and the Sun, or the Earth and the satellite, or any other mass. So once you know the masses multiplied by the universal gravitational constant, yes, that is when you're going to have the constant. Other than that, then this still becomes a variable. Yeah, so when you talk of equations, this is all what we mean by equations. In my next presentation, I shall be taking you through linear equations, so just watch out. Thank you.